In this video, we are going to talk about how to make an inventory decision with quantity discounts. So let's consider a situation where we have demand per year of 100,000 units. And we have a holding cost equal to 25% of the cost of the item, and the cost to place an order, which you also can think of as a setup cost, is $500. And our supplier gives us a different price depending on the quantity that we buy. So if we buy less than 20,000 units, so for different order quantities, we have a different cost. So if we buy less than 20,000, the cost is $2. If we buy between 20 and less than 100,000, the cost is $1.90. And if we buy 100,000 or more, the cost is $1.88. Alright, so first thing we need to do is we need to compute our economic order quantity. And the EOQ formula always starts out with a big square root, and we have 2 times the demand times the cost of placing an order, and then we divide that by the holding cost. And now sometimes you just use always the same cost always, but we are going to take the holding cost as a percentage of the value, which in this case is 25%, so 0.25 times the cost of the item. Alright, so for each of these 3 scenarios, we may end up calculating an economic order quantity. We're going to start with the cheapest EOQ, and if the order size, the EOQ for that, turns out to be bigger than 100,000, we can just stop. So let's see what happens here. So if the cost is $1.88, this is only going to be valid, be useful for quantities that are greater than or equal to 100,000. So let's compute our EOQ. So we have 2 times the demand of 100,000 times the, made my radical sign just a little too short. 2 times 100,000 times $500, and then we divide by the holding cost, which in this case is 0.25 times the cost of the item, which is $1.88. So if you put that into your calculator, we end up with an answer of 14,586. So is that bigger than 100,000? No, I'm sorry, it is not. So we are going to, in a little bit, think about, we're going to figure out what our costs would be if we used an order size that would allow us to actually get this price of $1.88. Now, according to our supplier, the only way we can get a price of $1.88 is to buy at least 100,000 at a time. There's no reason to so we can't buy the 14,586. That's not going to get us the price we're looking for. So we're going to have to look at an order size of 100,000, and we'll buy 100,000 at a time, and cost per unit will be $1.88. All right, so that was our first one. Now, if this EOQ had turned out to be in the range where this is the relevant price, that is, if the EOQ had turned out to be more than 100,000, we could stop right now. No need to do any more EOQ calculations. But obviously that didn't happen. So now we will look at the next most expensive price when the cost is $1.90. So in that case, Q has to be between 20 and 99,000. Okay, so same thing. We take 2 times 100,000 times the ordering cost of 500, and we divide by the holding cost, which in this case, as in the previous case, is 25% of the value of the item, but now the value of the item is $1.90. So put that into your calculator, and you'll see that we get an EOQ that's a little bit smaller, 14,510. And it makes sense that it's a little bit smaller because we're dividing by a slightly larger number. Instead of dividing by 1.88, now we're dividing by 1.9. It's a little bit bigger number, so we get a smaller answer as a result. Does this number fall in the range between 20 and 99,000? No, it does not. So, in a few minutes, we will look into total costs when the cost per unit is $1.90. And the order size is the smallest thing we can get away with that's going to get us in the range between 20 and 99,000. And that order size, of course, would be 20,000. So that is that one. So now, last but not least, we have to look at, okay, what if the cost per unit is $2 and the order size is less than 20,000? We use the same square root formula, so we have 2 times 100,000 times the $500 ordering cost, and then we divide again by 25% times the cost per unit, which is $2. So putting this into our calculator, we get EOQ that's, again, a little bit smaller yet, 14,142. Is this less than 20,000? Yes. So now we have an EOQ that worked out to be inside the range that this was the relevant price on. So we are going to look at the cost of buying 14,142 at a unit cost of $2. So these are the three cost calculations that we have to look at. So up here we got our ERQ calculations, and now we have to do the cost calculations, figure out which thing is going to cost us the least amount of money. Oops. I have to be careful where I wave my pointer around. Okay, so let's start with the first one, where we have, so in all these cost calculations, we are going to look at the total cost of some order quantity Q, and the cost is always the order size Q divided by 2 times the cost of the item times the interest rate, the holding cost expressed as an interest rate. So that part gives us the holding cost. Then we'll get the ordering cost, which is the annual demand, total annual sales, divided by the order size, times the cost to place an order, S, and then lastly we'll have the cost of the goods, D times C. Okay, so we'll start out here. We're going to look at a situation when the cost is $1.88. So this scenario right up here, and Q is 100,000. Okay, so we have total cost. So we start out with Q divided by 2, so that is 100,000 divided by 2 times the cost per unit, which is $1.88, times the holding cost, which is 25%, plus the ordering portion here, which is annual demand, is 100,000 for all these calculations, divided by the order size, which is 100,000, times the cost per order, which is $500, plus then we have the 100,000 units we're going to buy per year at the cost of $1.88. So, what do we get? We get that, put this part in our calculator, we get that the holding cost is $23,500. And then we get that the the ordering cost, the second part, we have 100,000 divided by 100,000 times 500. Gosh, can I do that math in my head? And we get costs of $500. Then we have 100,000 units times $1.88, so we have unit costs of 188,000. So total costs work out to $212,000 even. Okay, so that is the cost of buying 100,000 units at a time at a cost of $1.88, and we end up with total annual costs of $212,000. So now let's look at our second option up here, which is when the cost is equal to, let's write this, where the cost is equal to $1.90, and the order quantity is $1.90. The order quantity is 20,000 units. That's not showing up at all. So, same formula. Total cost is equal to Q, which is in this case 20,000, divided by 2, times the cost per unit of $1.90, times 25% is a holding cost, plus then again we have annual demand, which is 100,000 for all of these, divided by the order size, which in this case is 20,000, times a cost for the order of 500, plus the cost of the stuff, the cost of the goods. We have 100,000 units times $1.90. So, what does this all add up to? We end up with $4,750 worth of holding costs, and we end up with $2,500 in ordering costs. 100 divided by 20 is 5, times 500 is 2,500. Plus 100 times $1.90 is $190,000 in materials cost, giving us a total cost of $197,250. Alright, we're in the home stretch. Can you feel the excitement? Alright, last option is when the price is $2 and we buy 14,000 at a time. So the cost is $2. Q is 14,140. So we go to the total cost calculation. We again have Q. Q is 14,142. Let me, where I lose my cursor sometimes. That didn't seem right as I was saying it, to be honest. So 14,000. Ooh, no. Got the wrong pointer deal going. 14,142 14,142. So we take 14,142 as the quantity, divided by 2, multiplied by the price per unit, which is $2, multiplied by the holding cost percentage, which is 25%. Then we add on the cost of the orders. So we buy 100,000 units per year, divided by a order size of 14,142 times a cost per order of $500 plus cost of goods of 100,000 units times $2. So, looking at what we get here, we have 14,000 divided by 2 times 25, we get $3,535.50 as the holding cost, and then as the ordering cost, we get $3,535.57. And then for the cost of the goods, we get 100,000 times 2. Gosh, I don't know what that is. Yes, it's 200,000. So we get total costs of 207,071. So a few things just to notice about this last one here. We are at the EOQ, 14,142, which is exactly what we came up with here as our EOQ amount. And since we're at the EOQ, holding costs are $35.35 and ordering costs are $35.35. Now I had to round it just very slightly, so that's why they're off by 7 cents. But basically they're not exactly the same, but for practical purposes they amount to the same thing. So we look at our 3 options here, and we choose the one that has the lowest cost. So our decision is to buy 20,000 units at a time and pay a price of $1.90. So that's our final decision, to buy 20,000 units at a time, which means that we will have a cost per unit of $1.90 and total costs per year. Remember, we're figuring out the total costs per year of $197,250. So how did we do that? We used our EOQ formula, and we used our total cost formula, and what did we do? We started out with the information, the demand, the holding cost, the setup cost, and then we had this pricing information given to us by our supplier. And then for each cost amount, we started with the cheapest cost, because if that cost had turned out to be in the range that was the if this EOQ had fallen into the correct range, we could have just stopped right there, but sad to say, it didn't work out. So we did the EOQ, we got this quantity, it was less than 100,000, so we looked later at the cost of buying 100,000. Then we did the EOQ at the next cheapest price, and we came up with another EOQ, which sadly was not in the right range, so then we decided we would look at the cost of buying 20,000 at a price of $1.90. And then we did the EOQ for the price of $2, and we got this EOQ of 14,000, and that was less than 20,000, so we decided we'd look at the cost of that. Then we used our cost formula, and the only, as we're doing each of these different examples, there's only one part that changes each time. This order quantity, let's see here, let's switch to pink. The order quantity that we're looking at is 100,000, and then the order quantity here is 100,000, and then the cost per unit is $1.88 here, and it's $1.88 here. Then when we go to do this second version, the order quantity is 20,000, and the 20,000 shows up here. The price per unit is $1.90, that shows up here. $1.90 shows up here. When the order quantity is 14,142, that shows up here. And it shows up here. The price per unit's $2 here. Price per unit's $2 there. And so just make sure that when you do multiple calculations, you use the right order size and the right price per unit. And that's it.